So this exercise is related to the moles, and we did the first 6 questions. In question 7, for a moles question, you will follow a pattern. Like usually, the first part is by formula, second by ratio, third by formula. So calculate the volume of a chlorine gas at room temperature and pressure that reacted with 400 grams of titanium oxide. So we have the mass of titanium oxide, which is 400 grams. And we have the three formulas of the moles. What are the three formulas of the moles? Moles equal mass in gram divided by the molar mass. Moles equal the volume of the gas divided by 24. And moles equal concentration into volume. These are the three formulas which we use to solve the moles question. So which formula is valid here? First, second, or third? Which formula we should use here? So the first formula is valid here. The first formula is moles equal mass in gram over molar mass. So we'll use the first formula. And the first part, they're asking a relative formula of the relative molecular mass of titanium oxide. So for this, you have to use a periodic table. When you check the titanium, so titanium here is 48 and oxygen is 16. So the relative molecular mass of titanium oxide, so titanium is 48 plus oxygen is 16 multiplied by 2. Because 2 oxygen each is 16, so 2 will be 32. 32 plus 48, so that the total sum will be equals to 80. So we'll have the molar mass of a titanium oxide as 80. Now calculate the moles in 400 gram. So if we need the moles, we'll use a formula, and moles equal mass in gram over molar mass. So mass in gram is given 400 and the molar mass is 80 for titanium oxide. So 400 divided by 80. 400 divided by 80. What's the answer? That's right, it is equals to 5. So we get 5 moles of titanium oxide. The next, determine the moles of chlorine that reacted with 400 grams of titanium oxide. So we need the moles of chlorine, but we don't have any information about the chlorine, like we don't have its mass, we don't have its volume. So what we can do, we can use a ratio. And what ratio we will take? We'll take a ratio between titanium oxide and chlorine. So according to equation, if we have 1 mole of titanium oxide, how many moles of chlorine are there? 2. So the ratio between them is 1:2. So if the ratio is 1:2, and if we have 5 moles of titanium oxide, how many moles of chlorine will be there? X. So we just cross multiply. 1 is multiplied by X and 5 is multiplied by 2. So that will make 10 moles. So we have 10 moles of chlorine. Then calculate the volume of the chlorine. So chlorine is a gas. You can see here the state symbol. So how to work out the volume of the gas? By using a formula. And we have the this is a formula, concentration into volume, that is used for solution. And this one is for gases. So we use a formula, moles equal volume of the gas divided by 24. Why we cannot use a third formula? Because third formula is valid for solution. Like if we have acid, alkali, like aqueous solution is there, salt even. So we can use this third formula. But for gases, and how you identify it's a gas, chlorine, you can see from the equation, it's written the state symbol of a chlorine, that is gas. So for a gases, moles equal volume of a gas divided by 24. So moles of chlorine are 10, volume of the gas we don't know, and divide by 24. 24 is divided, other side it will be multiplied. So we get 240 decimeter cube. So that's That is the volume of the chlorine gas. Is it clear, this question? Anyone having a doubt in this part? Moving on to the next question. Question 8. ECl5 is reacting with lithium fluoride to form LiPF6. Calculate the mass of LiF needed to form 3.06 gram of LiPF6. Use the following steps. So you have to use the steps. Calculate the number of moles for LiPF6. What we have 3.06 gram of LiPF6. So which formula is valid to use for the moles? We have three formulas. Moles equal mass in gram or molar mass. Moles equal volume of the gas divided by 24. Moles equal concentration into volume. So which formula we should use?
First.
The first formula. So when we use the first formula, moles equal mass in gram, which is 3.04. And about the molar mass is already given, so you don't have to find. It's given that LiPF6 has a molar mass of 152, so you divide by 152. So 3.04 divided by 152. This will give us the moles, which are 0.02. Okay, so we got 0.02 moles of LiPF6. Then deduce the moles of LiF. So the first part we solve by using a formula, means the second part we'll solve by using a ratio. But what ratio we'll take? We'll take a ratio between the quantity which we have and the quantity which we need. So we have LiPF6 and we need LiF. And it does not affect, like if you write LiPF6 first and LiF second. So LiPF6 according to equation it is 1 and LiF according to equation it is 6. So ratio is 1:6. So if we have 0.02 moles of LiPF6, how many moles of LiF will be there? X. We just cross multiply. So 6 is multiplied by 0.02. What's the answer for this? 0.12. So we have 0.12 moles are there for lithium fluoride. Then we need the mass of a lithium fluoride, mass in gram. So again, we'll use a formula. So ratio formula. And which formula we'll use? Again, we'll use the first formula, that moles equal mass in gram divided by the molar mass. Moles of lithium fluoride are 0.12. Mass in gram, we don't know. But for the molar mass, what we have to do? We have to use a periodic table. So lithium fluoride, lithium is here 7 and fluorine is 19. So the molar mass of a lithium fluoride, lithium is 7 plus fluorine is 19. So 7 plus 19, 26. So this 26 will be multiplied to 0.12 multiplied by 26. That will give us the mass in gram for a lithium fluoride, which is 3.12. So we'll get 3.12 grams of lithium fluoride. So first part we solve by using a formula. The second we solve by ratio. And third one, again, we use a formula. So moles questions always have a pattern is there. First, usually is by formula, second by ratio, third by formula again. Question 9. In a titration experiment, is there we have 20 cm cube of a sodium hydroxide, which react with 25 cm cube of 0.1 mole per dm cube sulfuric acid to form sodium sulfate. We have the three formulas for moles. Moles equal mass in gram over molar mass. Moles equal volume of the gas divided by 24. And moles equal concentration times the volume of a solution. So if we need the number of moles of sulfuric acid, we have the volume of the sulfuric acid and we have the concentration of the sulfuric acid. Which formula is valid here?
Volume multiplied concentration.
Moles equal volume multiplied by concentration. So the third formula is valid here. So we just multiply concentration into volume. Concentration is 0.1 and the volume is 25 cm cube. So we have to convert into dm cube 0.025 divided by 1000. So this will give us 0.0025 moles of sulfuric acid. So first we solve by using a formula. The second, we'll use a ratio. Determine the moles of sodium hydroxide. So what is the ratio between the sodium hydroxide and sulfuric acid according to equation? If there are 2 moles of sodium hydroxide, 1 mole of sulfuric acid. If we have 0.0025 moles of sulfuric acid, how many moles of sodium hydroxide should be there? It will be X. So what we simply do, we cross multiply. So 0.0025 multiplied by 2. So 0.005 moles will be there for for sodium hydroxide. So first we use a formula, second we use a ratio. Third, again, we will use a formula, calculate the concentration. So how to get the concentration? Moles equal concentration into volume. The moles of sodium hydroxide were 0.005. Concentration we don't know. And what about the volume of sodium hydroxide? That is 20 cm cube, but volume should always be in dm cube. So it will be 0.02. We'll always divide by 1000 to convert the cm cube to dm cube. So 0.02 divided. So when we divide 0.005 divided by 0.02, this will give us the concentration of this solution in moles per dm cube, which is 0.25. So 0.25 moles per decimeter cube. And the last, it's a very common question you will find that sometimes they ask to convert the concentration from moles per dm cube to grams per dm cube. So if you want to convert the concentration from moles per dm cube to grams per dm cube, we multiply by the molar mass. So moles per dm cube multiplied by molar mass, we get the concentration in grams per dm cube. So what is the molar mass of a sodium hydroxide? You have to use a periodic table for that. So sodium, when you check the periodic table, it is 23. Oxygen, it is 16. And hydrogen, it is 1. So 23 plus 16 plus 1 makes 40. So what you have to do, this 0.25, which is a concentration in mole per dm cube, you multiply by molar mass, which is 40. That will give you concentration in grams per decimeter cube. So when 40 times 0.25 or 25% of the 40, what we'll get? We'll get 10 grams per dm cube. Is it clear, this question? Any doubt in this? So this is an exercise related to moles. As I mentioned, every session we'll do a question or two from this exercise because it's like 52 pages are there. So we'll solve during like every session, beginning of a session or sometime end of a session, we'll solve a question from this exercise.